What's up everyone, how are you doing? Today I decided to build something that I've been, thinking about for some time, a Slayer Exciter circuit. Well, if you are electrical enthusiasts, you may have seen some kind of a coil, looks like somehow a Tesla coil, and when you bring a CFL around it, it starts to, give light. That's what I'm gonna do today. Now, so let's just get right into it. Oh, don't forget to share, subscribe, and like my video, and share any comments you have on your mind. Okay, now I've made a Tesla coil just like this, a tower. Okay, now this is a Slayer exciter right here, as you can see it. All of you, this is an LED, this is a transistor, a resistor, and there are three terminals right here. These two of the primary, and this is the end of the secondary of this Tesla coil. Okay, now before I turn it on, let's just see the quick brief of this schematic. Well, there is a transistor right here, a transistor, an LED, a resistor, a power source, and the first. This is the primary and this is the secondary coil. The primary coil usually consists of a fewer number of turns, usually less than 10 turns. And this one is the secondary, which may be in hundreds turns. And the working principle, to just very brief it, is the same as I told you in my previous video. For details, you can see this image right here on your screen. That is the simplest schematic I yet found. Hope that helps. Okay, I brought the the Tesla coil, in a much darker room for you guys to see it. So I'm gonna turn it on and see something cool. Turning it on. Wow. That is so cool actually. Glows. And it has no noise, just like Tesla coil. Yeah, it's cool. Wow. Wow. That's cool. That's cool. Really cool. Well, that was interesting. Yeah, this tiny thing, lighted my CFL very well, which is fairly satisfying. Yeah, it lights up. But I'm willing to try this. Yeah, this is a ZBS driver. I'm gonna mount it on the Tesla coil and hope for something that I'm thinking about. Okay, now what I thought is connecting this ZBS circuit to the primary and generating a very high voltage source on the output. So this will be the plan. Okay, now I've connected the primary to my ZBS and to the power supply. Now we're gonna turn it on and we expect a huge amount of power on the outside. So let's do that. Okay, let's turn it on. Doesn't have any, doesn't work, I guess. Oh yeah, I remember. Yeah, there is a broken resistor inside, so I must move it right here, and I hope it works now. Ooh, ooh, ooh. Yeah, now it's like it's light. Yeah, as you can see, I'm connected to nothing. I'm disconnected. Maybe I'm connected to the ground. That's what makes this energy source really special, because I'm not connected to anything, and yet this light, this lights up when I run electricity through it, just like this. Yeah, and that's because electricity must travel in any way or in any form possible. So the current through this transformer goes through my hand to the ground, to the to the metal supporting this table, to the table, the furniture, to the insulator. Then it will travel up through the air and finally will come right back to where it's became generated. So yeah, electricity will find its way through it. Yeah, that is cool. So let's try with my new CFL lamp and let's see if it lights up. No, doesn't. Okay, doesn't work. To be honest, I don't know why it doesn't work. It is weird. But what will happen if I try to grab this thing? Let's try. Okay, these are the two ending, and let's see if there's anything to me. Ah! Ah! Mother. Well, let me explain. Well, the survey circuit, if you see my previous video, it works on around, well, more than 20,000 or 20k hertz, and at that kind of frequency, it doesn't, well, shock me. It will burn me. So no matter how much the voltage is, it will burn my skin. That's weird. Why? Wait a minute. If it is wireless, it should light just through the air, you know. But nope, does not light up. So I guess this ZBase doesn't provide much, well, doesn't much provide the power needed for wireless transmission of power. So yeah, that's sad, very sad. But there is a way for which we can detect this, well, phenomena, the wireless transmission of power. What I'm gonna do is to build a detector that can pick up the electron charge through the air. Maybe this transformer doesn't have enough, what do we call, energy. There's no energy that gives off through the air. I mean, there's a few amount of energy. So I'll try to pick it up and to see if it detects. So for that exactly, I made a small, well, this is what we call, by the way, if you can see it closely, this is called a Darlington pair. Darlington pair. It's, well, to be honest, I use this for detection of AC power line, which these things work on. So this is a Darlington pair, and by the way, this is a sound or alarm or a sound producing speaker. So yeah, we're gonna connect it right here. But before that, let me explain a bit about this Darlington pair. Okay, this is the, well, schematic of, well, Darlington pair. As you can see here, it consists of, well, in my case, 3 transistors, each connected to base and emitter, as you can see right here. Well, this is an antenna. This is an antenna which picks up an AC fluctuating energy. That energy is stored due to a parasitic capacitance between me and the source. So due to that, this antenna will pick up energy as small as a picovolt, which is very sensitive. So right here we connected it to a LED which lights up as soon as we detect an energy. So yeah, but in my case, I used a, well, a speaker to, well, so you can guys hear it when it's near an AC voltage. So we're gonna use this on my Tesla coil, and we're gonna hear a beep, I guess. Okay, now I've connected my Darlington, and, well, let's detect it. So I turned it on my ZVS. So let us see. You see that? There's a very slight amount of, well, voice, but you get what I'm saying. You hear that? That means there is a slight amount of, well, voltage around this Tesla coil or Slayer exciter in this moment. Yeah. What about if I do this? Ooh, you see that? So loud. Yep, that is super loud. But it's not good because it's obviously high voltage and my transistors could blow up. Oh, by the way, the transistors that I was using, well, it's classic 2N2222A BJT transistor. So yeah, that's cool. That's cool. Yep, that means there is a very high voltage. Oh, and I forgot, this Darlington is also detects wire cables because it helps, well, drillers or constructions not to, well, accidentally drill into, well, a conductor. So before that they detect it. Let's try to detect one. Okay guys, this is a well, a cable divider circuit for my divider. So let's do this. You see, there's current inside it. Yeah, this is very, yep, it detects small amount of voltage, as small as a picofarad. Imagine, it is so sensitive. so sensitive that if I just connect, well, for example, let's just say a wire, only one terminal. I grab one. Now, if I try to touch it, yep, you see that? Here, I touch it. It's because it's very sensitive. Yep. Yeah. So this was that for today, and well, I hope you enjoyed it and you like this watching this. Don't forget to share, subscribe, and be in peace.